I originally set out to do this presentation for estimation only, but it turns out that estimation doesn't really have a lot of value unless you know how to use it to help you make predictions and whatnot. So I brought in a bunch of other methodologies into this presentation as well. Velocity, Burndown, a few other things. So we're going to go over estimating stories, teamwork, best practices. There are some improvements we can do in how we work as a team. We're going to go over sprint planning, backlog grooming, a few charts that we should be using in Jira, velocity, Burndown, and finally definition of done. What does it mean to be done with a given feature or story? So I'm here to present new ideas to the group. I am not here to force anyone. A lot of these concepts I've tried to bring to the table here at a high level, mainly to avoid information overload. These concepts may seem simple, but they are very difficult to implement, especially at a large company-wide level or engineering group like we've got. First, we need to set our expectations. As mentioned, this stuff is not simple to implement, and it's likely going to require a full software development lifecycle revisit and potentially a full Jira overhaul based on how our current Jira setup is. So set your expectations. It is not going to be a flip of a light switch. Let's jump into it. Estimating. So we've got a basketball here on the right, and I would typically ask the group, what is the diameter in inches of this basketball? So if I had all of you send me a Slack private message right now with your estimate in inches as accurate as possible, you'd probably take maybe 10, 15 seconds thinking about it and then send me a message. But if I was to ask the entire group to agree on a precise inches numeric value, and we all had to agree on a single value, it would take a bit longer. And if I were to tell you that the entire success of our next release or our next quarter was to depend on this estimate, you guys would take it a little bit more seriously. And there would be a little bit more fear instilled in you guys. Hey, are we getting it right? What can we use to better estimate? Okay, but yours is a little bit too high, etc. We'd probably have a conversation for at least 30 seconds, if not a few minutes, before we came to a conclusion. And that seems ridiculous. We're doing something wrong by trying to estimate this way. There's a better way. Turns out the diameter is 9.5 inches. It doesn't really matter. It's just an estimate. Every estimate is going to be wrong. Our strive to be perfectly accurate with all estimates is an endless endeavor. Which is bigger? The question is pretty easy. This is the sort of estimating we should do, comparative-based estimating. If I was to ask the entire group, hey guys, for the next quarter, we need to do an estimate, and this is going to be a very important estimate. I need you to tell me which one is bigger and decide as a group. You guys would probably all sit there silently and say, hey, Kevin, I don't think we even have to talk. It's obvious. Great. That took about 0 seconds to estimate instead of several minutes with the previous form. This is how we want to estimate. We don't want to waste time estimating. We just want to do it quickly. So why are we so good at doing comparative-based estimating? Turns out that it's based on the evolution of the human brain. Caveman said, hey, I need a big stick to go bash some animal on the head. This one looks bigger than the other. I'll grab this one. Or maybe it's cold and they need a cave for their entire family plus all of their other kids or whatever. They compare the caves. One cave is bigger than the other. I'm going to go with that one. Pretty easy. The human brain was not designed to use a mental measuring tape to measure a stick. This is what we're trying to do by estimating in time. Trying to get the exact amount of minutes it's going to take to do something. It's not going to work and we're going to waste so much time doing it. We'd be better off asking a question like this. The two sticks on the right, they're different sizes. Which one's larger? Great, we know that. How many times larger is it in length? The bottom one is approximately twice as long as the top one. That took nearly 0 seconds. Again, this is how we want to do this stuff. So we're pretty good at estimating relativity. You can see create a hockey pool versus an update an existing hockey pool. It's about twice as big as the other. One rock is twice as big. This is how we want to do this stuff. So if we take a smaller story or a smaller task, like estimating the amount of M&Ms in the hand, it all of a sudden it becomes a lot easier. I can probably tell you there's about 10 to 20 M&Ms, maybe 15, something like that. It doesn't really matter, it's wrong, but I can pretty accurately say that because it's something very small. This is estimating like a very simple task, like adding a UI element to the page, etc. It's just a task in a larger scope of a bigger story. But if we try and take this and estimate how long it will take for a large multi-month project, it's all of a sudden like asking how many gumballs in the machine. It's nearly impossible. And it's going to be way off anyways. Many times we don't even know the full scope of what we're estimating. So I found this photo of this jar which is cut off, and we don't really know the length of the jar. It's sort of like estimating a can of worms. Once we open it, we don't know how big it is, and it's sort of there's a lot of unknowns, so we don't really know how to account for that when it comes to time estimating, other than just jacking up the hours by some unknown amount. So lessons learned, all estimates are wrong. Smaller tasks are more accurate, larger tasks are less accurate when it comes to estimating. And of course, we don't want to fall down the path on the right, which is we ask for estimates and treat them as deadlines, which is all too common among software groups around the country. So there's a better way. There's something called Fibonacci numbers. I'm sure that a lot of us have taken calculus or some form of math. You've come across this. Basically, what this does is it creates a pointing system. So rather than using time, we use these numbers on the bottom right: 1, 2, 3, 5, 8, 13, etc. This is valuable because the smaller stories can be estimated in smaller increments: 1, 3, 5, 8. And the larger stories, which typically have more complexities and more unknowns, can be estimated at larger increments to account for those unknowns. So the next one up from a 21 is a 34, because a 34 is a pretty damn big story, and we need extra buffer to be built into that pointing system. So here's another view of the pointing system: small, medium, large, 1, 3, 5. 5 is obviously going to be about 5 times as complex as a small 1-point story. That's kind of how we want to look at this stuff. Another fact is that Twitter login, the story, if we want to implement this Twitter login, it should include everything. Documentation on how the login works, refactoring on the previous login, analysis on the new login security, unit testing to make sure login works, designing the UI or even the architecture, QA testing, integration testing, and of course, development. Whatever it takes to do this. Too often, when an engineer or a team goes to estimate, we just estimate based on how long it takes to write the code, not necessarily all of this other stuff, which really plays into the time it takes. So we need to be considering all these factors when we go to assign a point or Fibonacci number to a given story. In addition to all of that stuff, the 3 main components that make up a story on how you decide where it falls on the Fibonacci scale is effort, complexity, and uncertainty. Time does not matter when estimating points. Forget about time. We'll go into that in more detail. So what if we have a task that is going to take 20 hours, but it's really simple and busy work? So I'd first ask, why are we doing some busy work? We are highly intelligent engineers who are skilled at our craft, and we're slated to do busy work? Can we automate it? I'd rather automate it than do busy work. This should be the exception, though. It sometimes happens, and there's a couple different ways you can deal with it. You can either slightly inflate the estimate because you know it's going to take more time for sure, or just leave it as the same and absorb it into the sprint. It really doesn't matter. It's up to the team culture. So I've sliced up the Fibonacci scale into a few different areas. the stuff on the right in red, that's way too big to even bring into a sprint. Those are too complex, too many unknowns. They need to be revised. Requirements need to be discussed in more detail, and it needs to be sliced up into smaller, absorbable chunks. These would be items that are far down on the low priority area in the backlog, which really haven't been looked at in more detail. As you move up the backlog, it becomes into the yellow area, which is actually still too large to be in a sprint, I would argue. The stuff on the left in the green area is the perfect size, 1 through 8. Those are absorbable and acceptable sizes. I know this doesn't really make sense right now because what is an 8 or what is a 5? I'll go into that in more detail. To reiterate, forget about time estimates. We'll talk about how we get time from points later. There is a calculation. Why points versus time? Turns out that time has a certain fear element. So when we start talking about time estimates when we're looking at work, many times the engineers start thinking, oh man, am I going to be able to get this done in time? I don't know. This is when fear starts creeping in, and fear creates stress. Stress doesn't allow us to think rationally, so if we can eliminate it by removing time from the equation and simply focusing on the work to be done, it will create less stress, we'll think more rationally, and have hopefully better estimates. Also, the communication improves when we start talking about how much work is to be done, focusing on the work rather than how long it takes. The discussion should be about the work and the details and the analysis of the work rather than analysis of the time. Ultimately, estimates don't really matter. If you look at brand new startups, which are just a couple people, they don't even estimate. They just get shit done. And it's super effective because they're able to disrupt industries like never before. So sure, estimates at our level, we're a little bit more mature engineering group. It helps us make decisions, and that's the value of estimates. But we should reduce the amount of time we waste on them, and we should spend more time building products. If we could get away without estimating, that'd be even better, but it's really not feasible in a group this size. Before we go more into estimating and the other stuff, we need to talk about how a software team should function. I've seen this on a few different teams. Mine is one of them, the team I'm working on, and I'm trying to change it. Team 1 includes John and Kim. This is an example. Engineer John estimates, implements, and deploys feature X over multiple sprints. Engineer Kim estimates, implements, and deploys feature Y over multiple sprints. You can see they're estimating separately. They're working on the features separately. I see it more like two different teams, Team John and Team Kim. Essentially, they're just attending the same stand-up, but they're separate teams. They estimate and do everything separately. What if John was hit by a bus? Oh shoot, he's the only guy that knew that one feature. We're screwed. Or what if Kim went on a long vacation and somebody's got to fill in for him, but he's the only dude that knows that area? This is called specialization. We always want to eliminate this if possible. We should be a team who John and Kim should plan, we should estimate, and implement everything together. We split up the work, and maybe we work on feature X over multiple sprints, and then work on feature Y. This is not always possible, or the best choice, but it's ideal. We need to have mobility between projects. So John could work on feature X, and then Kim works on feature Y, and maybe feature X is smaller, so John joins in with Kim on feature Y later, and they can both work together to finish up the second feature. So the mobility between the projects is really going to benefit the team for a lot of reasons. So now that we're sort of working as a team, now we're ready to show how we can plan and estimate together. So story pointing in sprint planning. On the left in this gray box, you can see we have sprint 1 completed. So those are the 3 stories that we completed in sprint 1, and we're now about to start sprint 2 planning meeting. We need to estimate a story D. We should be asking the questions like this. Is story D twice as complex as story C? Well, story C is a 1 point, so that means that it's a 2 point if it's twice as complex. Or what if we take this? Is it half as complex as story B? That would make it about a 4 point. Or there's no 4 point in the Fibonacci scale, so we'd round up to a 5. Or maybe it's not quite a 5, we'll bring it down into a 3. This is sort of how we do this comparative-based estimating. We look at our history and we use that to estimate the future stories. So how do we get sprint 1? We'll get into that. So this is how we do it. Customer reads a story, development team asks questions, we estimate blindly, we all, secretly show our estimates, we have a discussion because we don't agree. Very likely we're not going to fully agree the first time. Once we all agree, we're on the same page on the requirements, maybe technical debt, etc. Maybe the guy with the 5 point thinks there's technical debt. He's able to convince the team to increase the estimate due to that. And we re-estimate, show our cards, and we're all at a 3. We go with a 3. So there's tools out there to do this better. There's actually like little card sets that you can use in person that has the Fibonacci points on them. You all hold down your cards. On the count of 3, we show them, and we all compare. It's a way to blindly estimate. There's also some online tools for people who don't like paper like myself, where you can just do it on your phone or whatnot. Then the Scrum Master or Product Manager turns over all the cards at once programmatically. We show them, we talk about it. Regardless, the main thing is discussion. The main benefit of doing this is discussion because it helps identify gaps and requirements and technical debt and clarification. So the dude on the right who has a 13, maybe he doesn't fully understand the story and that's why he's inflating his estimate. Or maybe the guy on the right with a 3-pointer, maybe he doesn't understand the full scope of the story. He thinks that it's easier than it is. There needs to be a discussion on there. Maybe the guy with the 13 insists that this area is super complicated and there's going to be a lot of defects. He's worked in this area previously and is able to advise the team of that. Well, maybe you can help convince everybody to get up to an 8-point or maybe all the way to a 13. That needs to be negotiated between the team members. But the results of a good discussion are this. Typically, we all think we see everything the same until we put it on paper or in Jira. We talk about it. Oh, estimates were actually wrong. We need to get clear on what it actually is. And then we finally all agree. So we're really envisioning the same thing. This is like the result of a discussion based around those estimates. So common mistakes during planning poker, everybody's afraid to be the odd one out. If everybody else is a 4-point and you're a 21, it doesn't make you an idiot. It simply means that maybe you don't fully understand the story and they need to go into more detail. Or maybe you haven't worked on that area before. That's completely acceptable. So don't be timid, be honest. There is a question mark card and use it. If you don't know, it doesn't make sense to just throw out any random estimate. Common mistakes, I've seen this on at least one team. QA and dev are on different points, and for some reason the Scrum Master decided to add them together to make it 13 points. Cool, we get a 5 plus an 8. No, that's not how it works, guys. We need to agree. If dev is at an 8 and QA is at a 5, maybe it's more work for dev because they have to write all these unit tests versus QA does a 5-minute pass through to go check it. Dev needs to say, hey, it's more work for us. QA, you need to come up. So the agreed estimate would be an 8. Sweet. What happens if one engineer has a low estimate compared to everybody else? So maybe the engineer insists that the story is a 2-pointer and the rest of the team is at 8. There's a few different ways we can handle this. We can just have the superhuman engineer do the work and leave it at a 2-pointer. Well, that's sort of like just kicks the can down the alley of specialization. We're not really spreading the knowledge against the team. I've also seen where we take the low estimate and use the experienced engineer as a resource for whoever actually does the work. Or I've seen them take the estimate of the one doing the work. But the real question is, what about QA? QA is at an 8-point? Why is that? Is it more work for QA to do the work, to actually test the product than it is to develop it? There needs to be a discussion. Are sprint defects estimated? Typically, no. Sprint defect is basically a child of the original story that was committed to within the sprint. So it's technically part of a scope of that original story. So no, there's no need to defect it or to estimate it, because until that defect's done, that story is not done. So therefore, it's a part of the sprint. It's part of the original estimate. What about production defects? Yes, they are. Production defects found, it should be placed on the backlog, prioritized, and estimated accordingly to be pulled into a future sprint. So how can we estimate very quickly? I've had the pleasure of being a part of some tightly integrated, high-performing teams, and this is how we did it. Typically, we're really in sync, on the same page. It's sort of one of those teams where when we hold up the cards, 9 times out of 10, we're all on the same page. We all have the same estimate. We've done this a million times. It is possible, if you've come to the sprint planning or backlog grooming meeting prepared, things sliced out, that you can estimate each story in 2 to 5 minutes, if not less. That's estimating potentially 30 stories per hour. And at that rate, it is possible to estimate like a 6-month-long roadmap in just a few hours, which is so cool because we can do predictions based on those estimates to figure out the timeline based on velocity. So we'll get into that later. That's that's conversion from points to time, and there's a certain calculation for that. So summary again, why not estimate in time? Well, it wastes too much time. Stress detracts from accuracy, and we should be focusing on the complexity rather than the time it takes. Backlog grooming. This is a regular weekly or bi-weekly cadence meeting where we basically estimate all of the stuff in the backlog. We talk about it, we slice it up, we estimate them. It's where conversations happen. Ideally, the stories will be sliced before coming to this meeting so we don't waste time in the meeting. But sometimes that doesn't always happen. So here's a view of the backlog. And you can see the stuff on the bottom is low priority and the stuff on top is high priority. The high priority stuff has been dug through, it's been sliced up and estimated and fully understood and thrown at the wall several times to see what sticks, and it's ready. It's finally revised and ready to be pulled into the sprint. Some of the stuff in the middle we've reprioritized. It's larger epics. We're learning what is a higher priority, and stuff on the bottom is sort of really vague and higher level epics, which are too big for us to understand right now, but we'll get to them. This is how it should look. Or here's the reverse, right? It shows they've split it up into a sprint backlog and a product backlog. And look, the product backlog has story points at 5s and 3s, which is perfect. They're about ready to be pulled into the sprint. The epics, the stuff on top, is all 100s. Those are just too large. They haven't really been fully thought through yet. Sprint planning meeting is a regular cadence meeting at the start of each sprint. Essentially, in this meeting, we should have all of our stories prioritized and fully estimated so that all we have to do is simply say, hey, based on our previous amount of work we've gotten done, how many points can we take in? And we just simply drag them into the sprint and we randomly assign them. Velocity. This one's important. So this is the average amount of time or average amount of work that your team can complete in a sprint. This is calculated based on historical data. And it's also calculated based on stuff that is actually done. You don't get credit for it unless it's done within the sprint. So here's a velocity chart, and the red line is the actual velocity. Velocity, remember, is the average amount of work that you're getting done. So you can see, they've gotten several different amounts of stories done in each sprint, and again, this is the total of points within the story. The one on the left, 221, That's way too much. I don't know of any team that's ever completed that much. The scale is off here, but you kind of get the general idea. You can complete different amounts of stories in each sprint, but over time, you'll start seeing a trend that the sprint usually completes around X number of stories, and that is the velocity. If you notice from left to right, the red line is slightly increasing, and that's because the team is settling into a flow in which everybody has their roles and they're becoming more high performing. This is what we want. We want to focus on increasing velocity and getting more work done every sprint. So why do we care about velocity? Mainly so that we can make predictions. We can answer questions like, hey, how quickly could we develop and release feature X? Well, maybe we've gone through and sliced the slice the feature X into 110 points. Well, team A velocity is 15 points per sprint. That would mean it's 7.3 sprints for that team alone. Same thing with B, they have a different velocity. But what if we put them together? Then we can do a different calculation where it's almost 3.5 sprints for both teams to complete this story, which is cool. We'll go into more detail on how we get this calculation in a bit, but that's not really going to work unless both teams are on the same scale. So Team A would estimate story X is 8 points, and Team B would be a 3-point. That's not going to work. We need to be on the same scale. So both of the stories would be about the same between the teams. And we can do that by agreeing on a common template for all the teams to use and compare against going forward. So for example, 0 points. This one is almost no work. Fix the spelling of site map to site map on the footer. It's a simple 2-minute change. I don't even count that as much effort at all. 1 point, implementing a tooltip for field X using a common tooltip control. Oh, no sweat. 2 points, about twice as complex as the previous, implementing a field X required validation with the UI prompt. Slightly more complicated is adding additional field to save the business owner's marital status. A little bit more, basically twice as complicated as the 2 point, adding the delete functionality to delete a given loan application. Slightly more complicated, almost twice as complicated as the 5 point, adding a bulk delete functionality with checkboxes on each to delete the loan applications. 13, about twice as complicated as the 8 point, adding a new section to loan application to collect and save mortgage info. And finally, integrate with Wells Fargo API. What the hell? We don't even know what that is. Question mark. So now that we have this common story template, we basically are able to answer this question, right? It's really 3.3 sprints for both teams to do this because they are on the same scale. It just turns out that one team is a little bit more productive than the other, which is common. It's fine. Maybe they have an extra team member or they have an intern. I don't know. So again, guys, I've seen this before. 1 point equals half day or 1 day, 2 points, 2 days. No, forget about any of this crap that you guys have heard previously. This is completely wrong. Forget about time. So this stuff is great, right? We have sprint 1 completed, but we want to get started on sprint 2 planning, and we compare against sprint 1. But what if we don't even have sprint 1? How do we get sprint 1? Well, good question. First thing we do is we'll estimate a given set of stories, probably 20 or 30 of them. I don't know, whatever's in the backlog. And then we'll prioritize them and then pull into sprint 1 as many stories as feels good to the team. So this is going to be not necessarily the best accuracy, but you need to stare at the stories that are in the sprint and say, hey, do you think you can get that done? Just by looking at the descriptions of those stories. As a team, if you can agree, commit. Cool. And whatever you guys get done within that sprint is your new baseline, or it's your initial velocity. So if you committed to 20 and you only get 15 points done, then 15 points is your new velocity, and you will only take in 15 points for the next sprint. So again, how do we get those estimates from the initial stories that we did in step 1? we compare them based on the stuff you see in the bottom right here. Take a given story, read it. Okay, try and figure out where it fits on that. Is it between a 3 and a 5? Maybe they think it's a 4. No, if it's a 4, that means it's a 5. We go typically go the higher one up. All right, what's the difference between a story and a task? So we've got a story, we estimated at 3 points. As a user, I'd like to add a new marital status field in a loan application. And with that, after we've dragged it into sprint planning, typically what we do is we'd add some tasks in there to actually accomplish that. We'd have some for QA, one for unit tests, one for the new DB column, etc. And we do put time estimates on these because they're very small. Again, M&M's in the hand. It's very easy to estimate very small tasks. A few notes on this. I've worked on teams where we don't even create tasks. We're just so in sync that we kind of know what to do and we can just figure out what to do from the story alone. I've even seen teams where they don't put time estimates on the task. They just create the task to remind them to write the unit test or to do the impact analysis. They don't need hours because essentially hours don't matter anyways. Sprint planning best practices. Commit to no more stories completed in the previous sprint. No more stories that the points were added to in the previous sprint. If you finish all the sprint work early, you can always pull in more stories and take on extra credit and be a hero. We recommend you randomly assign the stories or tasks to the team members, and this will eliminate specialization. What about actual hours? Typically, this is the question presented to us by upper level management. We want to report on these actual versus estimated hours because we need to know how everybody's doing. Are they doing their job? Well, we understand the value that you're trying to get from that, but unfortunately, actual hours don't really work. They might work if you're a contractor or if you have billable time where you actually need to bill a customer and that provides value in that way. But it's so common for us to lose track of time because we're helping out another team member on his task. In reality, we're engineers and we don't necessarily keep a time clock on our desk that we punch in and out of for each different task that we do. So when we're filling out actuals, I guarantee you that we're all filling out the wrong stuff because unless you have a stopwatch on your desk, it's all an estimate for the actual as well. And it's so common for engineers, they put, oh, what's my actual? Well, I think I spent about the time that I originally estimated. So, you're reporting on this bogus data, which is we're supposed to review the actuals to see how off we are. Well, it turns out that the actuals are estimates too. It's insanity. So what can we focus on to actually provide value to upper level management? The main thing is the team's velocity. Is it increasing? Are we getting more work done consistently on a sprint basis? Also, we need to be looking at the carryover. So if you completed 15 out of the 20 points of stories that you originally committed to, well, 5 of those stories were not done or they were half done. Why is that? We're having some commitment issues where we're not completing everything. That's not good, and we need to look in that in more detail. But the main thing is the team growing and progressing on the Techman scale? We want high-performing, tightly knit teams that kick ass in developing software. And velocity is a good indicator on that. Definition of done. What does it mean to your team? Fully tested, unit tested, documented stage for deployment. Typically, it doesn't really make sense to have deployment part of the done because that's usually done at the end of the sprint. So you need to get credit for the actual story somewhere in the middle. Typically, stage on deployment and tested by QA on deployment, deployed on the stage server and tested on QA on the stage server. That could be a quasi definition of done for the engineering group. And that matters because the Jira ticket flow is essential. And you'll see in a little bit velocity and burndown charts. Those are basically triggering based off of this done status in Jira. But don't I at least get partial credit for building this rickety bridge which does not align? No, if there's defects, you don't get credit. It gets pulled into the next sprint until you finish the defects. So if there's no partial credit, won't that screw up our velocity? Velocity is the average, guys. It's not going to change anyways. The goal is to not have any carryover, but if there is, it might screw up your chart, but it's not going to screw up the average. So where these arrows are could be because in the previous sprint they didn't finish everything and they pulled it into the next. Because they were pulling in stories that could have been 90% done already, they knowingly overcommitted in their next sprint because they knew that they were going to get done early with those stories because they only had 10% left to do. That's just an example, but again, only the stuff that gets done is actually counted on this chart, and velocity is an average, so it will average out over time. Commitment. Commit only to the amount of points marked in the done column in the previous sprint. I say done because there's a difference between done and done. Done means, hey, I'm done adding this UI element to the screen. But are you done with the story? Like done with testing, done with deploying to staging? All of that is what I consider done. So if you finish everything and everything is done within your original completed sprint, great. And you have a couple days left, pull in another story, get extra credit, build up your morale. So this will all work just fine, but we cannot interrupt the sprint. One of the main things is we need to protect a formalized commitment. If we expect to be having a formalized commitment, then we also have to protect it. So small changes can be absorbed into the sprint if we can all agree, like changing the color of a font or changing an icon from one to the other than what we originally wanted. Not a big deal. Maybe even like some different validation logic. If it's not a big deal, we can agree to commit to it. But any significant sized work that's changed in scope based on a story that we originally committed to, that needs to likely be removed from the sprint, reanalyzed, re-estimated, and then pulled into the following sprint. If we do take on significant changes to a sprint or to a story, it's going to screw up our velocity, screw up our commitment, and we're probably ended up dragging in stories from one sprint to the other, which is what we don't want. We want to formalize the commitment. So I show a bodyguard here because this should be the bouncer or scrum master or product manager who protects the scope of the sprint. So calculating time for a large project. Team A has 2-week sprints. The team has an average velocity of 20 points. Maybe they have a feature which is 53 stories totaling 220 points. There's some math there. You divide total stories divided by velocity, and it's going to take 11 sprints to complete this, or 22 weeks. This is how we get from points to time based on velocity. You can do this very similarly with another team, which might only have a 10-point velocity, in which case it would take, 22 weeks? I'm sorry, 22 sprints, which would be 44 weeks because they're half as effective at completing work on a sprintly basis. So what's a burn down? Are we tired of the project managers hounding on us on a daily status meeting? Hey, how are you doing today, Kevin? Are you about done for this sprint? How much more time do you got? I don't know how to answer that. I almost dread those questions asked to me because I don't know. I mean, I can give you a gut feeling, but it's not going to be accurate, and I hate to give product management any accurate sort of any numbers based on my gut feeling. So a burn down can prevent that. Burn down basically tracks us on a daily basis to see how we're doing, if we're going to meet our sprint deadlines. This is what it looks like on the bottom here. So here's what a burn down would look like mid-sprint. The red line is ideal, and the blue is the actual stuff we have left to do. As we progress down the sprint, we knock out some of that stuff, and you can see that we're doing pretty good here. We're pretty much on progress. In this perspective, we can see that in the beginning of the sprint, we were behind schedule because we had more to do than what was ideal. And now we've caught up and we're now ahead of schedule. This gives us a pretty good pulse on what's going on if we're going to make our sprint deadline. So what if we want the delivery status of a specific individual on the team? Why do you want that? Is your team really working as a team, or are you guys working as separate individuals on separate projects? Or is there a burn down chart for a specific team member? Nope. Same question as above. So in a sprint, there's really only two variables. There's time and scope. You can't do anything else. Need to add a feature, project timeline needs to be pushed out. Need to release sooner. We need to punt features to the next sprint. Adding additional people to the team is typically a way that product tries to mitigate this, and that doesn't always solve the problem either because we end up spending more time trying to train those people on the given feature. Also, overtime is, I guess, another solution, but I guarantee you the team's going to get burnt out and start leaving the company. So how does sprint overcommitment affect the team? The guy on the left is overcommitted, frustrated, doesn't enjoy his job, everything's half done, versus the guy on the right. The little kid on the right is how I want to feel at the end of every sprint. Delivered just in time, happy, positive morale. Let's go grab some beers and do it again next sprint. Perspective. So this is sort of a story about a couple different teams that took different perspectives on how they committed within their sprint. The first, Team A, committed to 20 points. They actually only completed 15 points by the end of that sprint, and everybody was bummed out because they didn't finish everything. Management was disappointed, all their peers were disappointed. Why is everything half done? Team B committed to 13 points. They finished early. They pulled in an extra 2-point extra credit story, and they were stoked about that. They completed 15 points as well. They have positive morale. They're stoked. They pulled in more. They want to celebrate next and do better even next sprint. It's essentially the teams are completing the same amount of work. It's just different perspectives. But I'm sort of big on morale, and I think that majority of us in the room would rather be a part of Team B. So got to remind you guys, change model. It's not going to be easy to do this. There will be chaos if we decide to take this first step, but it will get better. Just be prepared that as everybody finds their place in the new team, the new process, chaos will occur, and slowly but surely we will be a better team overall.
All right, guys. So I got some requests to go through a slicing presentation. Put together a little fun presentation here for you guys. So quick overview on slicing. I think it's probably one of the most complicated and difficult pieces to master from one of the Agile methodologies. So I figured I'd kind of give my take on it and what I've learned over the years dealing with this and on different engineering groups. So let's get started. Overview of topics. What are we going to go over? Types of requirements, user stories. What is a user story? How we slice them. The concept of the Pareto principle. Push versus pull system, and then some final thoughts. So let's hold all questions till the end. We got a lot to cover. Got the slide numbers in the bottom right. So if you guys just notate that, I can pop back to that slide and we can discuss it, whatever your question was. All right, so to be clear here, guys, I'm not here to force you guys to do anything. My goal here is to present new ideas. And if you guys see value in it as the organization or as a team or as an individual, try it. As engineers, we should always be learning something new. I don't think forcing something onto a large group of people is the best way to achieve any sort of progress. Software requirements. So as engineers, we typically don't really want to talk in depth about software requirements, but we have to. I know we just want to get to code already, but I'll try and make this relatively quick and hopefully this will provide some value to this phase of the development process. So our current requirements format, most of the product managers, from my understanding, are doing them in like a Publisher or Google Slides presentation to kind of go through the different UI elements. They use arrows, comments, etc. They write the requirements out. There's nothing wrong with this. In fact, I think it's pretty good. But I think that we can do better. So this is sort of the hierarchy of the different types of tickets that we use in Agile. Project, there can be many features under a project, many epics under a feature, many user stories under an epic, and many tasks under a user story. But right now, from my interpretation, most of the engineering group only uses essentially a feature and tasks to deliver that feature. Essentially, the slides that we saw on the previous screen would be the feature or epic, depending on how you interpret that. That's up for debate. And then the engineers go and they create tasks and estimate the tasks. And then they will start delivering maybe some of the tasks if they get a chance, or not ideally, they deliver all of the tasks all at once at the end of the sprint. That's what we want to avoid. So we're missing the user story. And so I'm here to provide you guys with sort of an overview of the user story and the value that it can provide. Writing user stories. All right, you guys may have seen this previously, and it sort of sounds ridiculous, but there's value in this. As a user, I can do something so that I can get some value. Everything that we work on should provide value to someone. So if we can write a story out in this way, especially if we have the user role, we know who we're providing value to. The business, the product manager, sometimes the engineer, but very rarely, but most likely the SageWorks analyst user or product X user. User story examples. As a student, I can get a degree online so that I do not have to move near a college campus. As an online student, I can print a copy of my last report card in case an employer asks for it. Both cool stories. They don't really go into detail of what exactly needs to happen, but obviously the value is there. Those might be epics, and they're formed the exact same way. So this is a requirement that I worked on over the last sprint or so, and I still think we're working on it. This is the epic. I wrote it out so that we can more clearly understand it in one sentence rather than looking through 10 or 12 different slides. As a SageWorks analyst user, I would like to pull client credit reports and associated data from universal credit reports so that I can make an educated decision for funding a loan or other financial product. Makes sense. You know exactly what it does from a high level. And it makes it really easy to look at this in Jira and be like, oh yeah, that's that story. I'm going to work on that at this point in time, or that's that epic. So that's just kind of me taking one epic and slicing it or putting it into a proper format so that it can be legible. We'll go ahead and slice this epic later quickly, show you guys how I did it and some of the methodologies I used. All right, slicing, horizontal slicing. Typically, as engineers, I don't know what it is, but our brains are designed to slice the product horizontally. Intuitively, it doesn't make sense to do it vertically. So typically, when we start on a project, the first thing we sometimes do, we'll usually start writing out the database schema. And maybe we'll spend a whole day doing it or whatever. We'll plan out all of the different fields that we need, and we'll put them all in the database so that they're there and they're ready for us when we need them. We might need them in a few weeks. We might need them tomorrow. We might need them in a month. But usually, we want to do the full database schema before any work is done on the client or the server. Usually, not always, but that's typical for the case. Then we'll go to the server side. We'll write all the web API methods, all the data adapter methods, etc. And then finally, we usually come to the UI and start implementing all of those different server methods. So the problem with this is that at any given phase, there's 3 phases here, if we do it in that order. At any given phase, as each one is completed, we don't have a deliverable product. So essentially, if this was take a couple weeks long or maybe a full sprint to do this given task or product or feature, we don't have any deliverable until everything's done. And the vertical slicing argues that that is not good. Agile argues that that's not good. We're delaying all the risk until the end of the project. So I'll show you guys on a quick example, a visual of how we would build a Golden Gate bridge using the unideal horizontal slicing approach. Phase one, build the foundation. We're going to take enormous pillars or piers and drill them into the channel. They're going to go down, I don't know, 1,000 feet, 500 feet. Now remember, we're building a 6-lane bridge, so this structure has to be enormous. We need to plan for this 6-lane bridge. So we've got to install these enormous pillars that you see on the right here, and there's several of them. So we're essentially laying the foundation. And let's just say this takes 6 months to do this. When it's done, do we have a deliverable product? Nope. Next, we're going to start building the lanes. We're going to go 6 lanes all the way across, and we're going to try and meet from one end to the other. We got about 75% of the way, as you can see here in the Google Maps image. And let's say that took another 6 months. Now, perhaps there was a new mayor elected for San Francisco, and she decided, hey, I want you guys to build the bridge to this new sandy area over here instead. And he changes the scope on us. And like most engineers, you probably feel like this dude on the left from Pulp Fiction. It's frustrating. And you obviously, I think I've estimated out, there's probably 4 months of wasted work there because we had an extra pillar going the wrong direction and some extra bridge as well. So that's really frustrating. We wasted time trying to achieve all 6 lanes at the same time. So there's a better way to do it. So I want to preface this with the notion that some of the ideas that I'm going to present here seem absolutely ridiculous. I remember the first time that some of these ideas were presented to me, I was very resistant to change. And I did not embrace this for probably a year or two. So let's keep that in mind. So the idea is vertical slicing. You do a single slice which touches all 3 layers or all number of layers that you have. Maybe it's more than 3. And you essentially deliver each slice individually to the user. All right, so how can we build the Golden Gate Bridge using vertical slicing? Mark, if you can unmute, do you guys have any ideas on how we can do this? Maybe someone in the audience knows the answer.
Lee knows the answer, but he's not going to spoil it for the rest of us.
Oh, okay. Does anybody else know? So the idea is we want to deliver a single piece of the bridge in a fully workable fashion within a month or 2 instead of a full year. All right, I'll move on. The answer is a single lane. Seems crazy, I know. It seems absolutely ludicrous, and it is, but it works. So the idea is we will build not an enormous foundation. We're going to build just enough rickety foundation to support this one single lane. We're going to build the Golden Gate Bridge with a single lane. And you can see on the photo on the right here, the photo that I found is like, it looks like it's actually made out of wood planks on the bottom. That's great. It's just a simple, almost prototype to see if the users of San Francisco even use the bridge. And we can deliver that within a month, potentially. And if they don't use it, well, great. We didn't spend much time building it. Awesome. Save the money a ton. Save the city a ton of money. All right. So after the first month, we deliver it, and they've been using it for a little bit. We want to improve it. We do the next slice. 2 lanes. We upgraded the architecture. So we upgraded the architecture. We can see now that we had a little bit more robust architecture. We're using steel beams. We're using a concrete paved pathway. And look, people are using it. Cool. There's a pull so that we can add more lanes because people are using it. This was delivered after the second month now, right? And then eventually we would deliver all 6 lanes and have what we have today. So many people would ask, Kevin, that seems ridiculous. Look at the pillars and the beams that are involved in this Golden Gate Bridge. They're enormous. How are you going to upgrade that over time? You're going to have to rebuild the thing every time. Well, I agree when it comes down to structural engineering, but software is much more malleable than this. So we don't necessarily have to tear it out every time. We can use adaptive architecture. So some ways on how we've done this. The idea is that you have just enough architecture just in time. Toyota Warehouse did this. Toyota makes tons of cars and they have millions of parts. And if you can imagine, they had a warehouse situation where they had millions of parts and it's expensive to store all these parts. So Toyota invented a process called just enough, just in time, so that the parts arrive at their warehouse just in time so that the next hour or the next day, that part is going on the vehicle. That way they don't have to store this stuff for an endless amount of time, which costs time and money. Empire State Building used adaptive architecture and just enough, just in time technology. The story goes, well, the way it was told to me, Empire State Building was built in a way so that they could essentially put a cap on it at any time. If they ran out of time or money while doing the project, they just throw a roof on it for whichever level they just finished and call it a day. They also did it in a way, Empire State Building was built in the middle of a city. And so it was difficult to store all of that material in the middle of the city. So what did they do? They had trucks truck in just enough material so that it wasn't sitting on site because there's no room for it. So that when the material arrived, it was going up an hour later. So the material was there just in time. And we would like to do that with software architecture as well. It's very difficult to not do this though, or to do this properly. And I say this because as engineers, we're always thinking to the future. Well, what if we did this in the future? We need to design this entire service to do this because we might want to do this in the future. Well, that could be argued that it's over architecture. We should do just enough for what we need right now. Now, if you're going to do whatever you think you're going to do tomorrow, that'd be a different approach. But if you think you're going to do it in 6 months, well, priorities could change. We could not even take on that. And then we have this enormous architecture for no reason. You wasted your time. All right, vertical slices of horizontal slices. So this is sort of the idea, cake. Pay order with PayPal, pay order with credit card, pay order manually. We would deliver each slice individually to the user or to this kid up in the upper right. All right, slicing, real world scenario. We've got a contact management app. You can see we've got these different fields here. We've got some edit or and a little pointer on. We've got some edit functionality, delete functionality, add records. Challenge for you guys. Can you guys slice this into maybe 4 or more vertical slices with each slice being deliverable? Do you guys have any ideas?
So, Kevin, one thought I had was like just to print out the data without any of the actions associated with it.
Perfect. Perfect. Yes. What's another slice?
I'd say probably add records after that.
Yep. You guys are already experts then, you know. All right. Yeah, this is sort of how I sliced it. I'll go through it. All right. I actually just did first name. It sounds ridiculous. I know. You guys look like this guy on the right. As a user, I would like to store a list of contact names and view them on a page so that I can track my contacts. We could probably do that in 10 minutes and release it to product. And they can go test it and Maybe we'd manually put some data in the database for them to go there and view, and testing it would be just viewing it. It sounds crazy, and it might be for this sort of small application, but in many cases, we're dealing with very large features, and many times you have to slice it a lot smaller than what you would think. All right, here's all the contacts. This is what you would have done first, Mark. As a user, I would like to store a list of contacts with relevant information and view them on a page so that I can track my contacts. Next one, add contacts. As a user, I would like to add contacts with relevant information so I can store more people. So I would argue that potentially we could release this to some users to see if they even use the application. I mean, before going into edit and delete, this could just be a learning experiment and release it to 1 or 2 users in whatever system it is. And maybe we track them a week later and see if they've even added any contacts, period. If they haven't, well, are we even designing the correct thing, the correct product for them? This is sort of the lean startup model, is that you learn. We want to get the product to them as soon as possible to learn how to use it. All right, here's the delete. As a user, I'd like to delete, etc. All right, so do we have a working application? I think so. It's not ideal to have to delete and then re-add to edit somebody's email, but it works. I mean, we could release this to production, and if we're at the end of the sprint and we don't have edit done, that's not ideal, but the user could probably use it for 2 or 3 weeks until we get the edit implemented. So edit functionality really is not MVP, depending on who you speak to. By MVP, I mean minimal viable product. And this sort of brings out the Pareto principle, which is true in most business industries. Essentially what this states is that 80% of the effort really only generates 20% of the revenue or 20% of the result to the user. And that 20% of effort generates 80% of the result. In many businesses that maybe like a retail business, it offers, I don't know, bathroom products, whatever it is. A lot of them realize that, hey, there's only really, if they've got 100 different products that they sell at Walmart or something, 20% of them are the top sellers, and they generate 80% of their revenue. If you guys go watch Shark Tank, you guys will see the sharks talk about this too. It's true in most industries. So in a previous job, I actually had a Keurig coffee machine. I don't drink coffee, but I remember my previous coworkers telling me that there was defects in it. And I remember looking it up, and they're actually a $1 billion brand. And this $1 billion brand has a coffee machine, which I don't know how much they are, 50, 100 bucks, but it has defects. And this company is making sales in the billions per year, and probably just this model alone in the multi-millions. Now we could try and think about what happened there. Maybe they created hundreds of thousands of them. The CEO or the executive just decided to push it out anyways. Well, they probably made a good decision because the company's doing great and they did not over-architect it or put too much effort trying to perfect it. It works just enough for the user, and it was able to allow them as a company to strategically position them to corner the market. That's the idea. Quickly go over minimum viable product. Minimum viable product sometimes is used in a different way than what it actually is. A lot of times when we ask our product managers to give us the MVP, only the stuff that is necessary, it's very common for them to give us too much and say, hey, we want all of this stuff because we can't sell it to the customer unless we have all of this stuff. Well, that's actually a minimum marketable product, a product we can sell, or minimum marketable feature, minimum feature we can sell to the customer. MVP in some cases, or in most cases, should be focused on learning if and how the customer uses it. And this is part of one of the lean startup methodologies. They really want to learn the impact of learning how the product is used. So in a lot of cases, potentially, if you're, I don't know, a company that's trying to sell a skateboard, you don't even build the skateboard. You create a mock-up of what the skateboard might look like, and you put it on Kickstarter, and you see the response. that could be argued that that Kickstarter campaign is a minimum viable product because they did no work, but they put the concept out there and they saw if, hey, do people actually want this? We're learning. So you can see in the example below, the tire is not a product. The tire in the frame, still not a product. So we're building a car, and potentially maybe we're building a product for someone who lives in New York City. Well, a car is not going to do them any good, but they would only learn that by the time they got to step 4. If they had built maybe a skateboard, they would learn, hey, yeah, people are using a skateboard, but I think they'd be better off using a bike. They'd get to step 3 and they'd probably stop because people in New York City, I think they use bikes. Well, I'm sure they use bikes more than cars, so they wouldn't waste their time building a car, and they would have learned earlier, faster feedback loop. All right, so here's the final, the edit contact. You can see a little edit icon there. As a user, I'd like to edit, etc. All right, so I know some of you are sitting there with this look on your face, like these 2 white chicks. Why not build the entire grid at once? Kevin, that's such a simple grid. I could probably do that in an hour or 2. Great. Well, let's go through why. A few different reasons. Slicing. All right. Now let's add a new story here. Emergency contact. Apparently this is now going to become an app for your phone, maybe? I don't know. As a user, I'd like to mark a single contact as my emergency contact so that rescue teams know who to contact if I'm injured. And let's say that product is designing this entire grid specifically to add value to the user to mark their emergency contact. So this is essentially the #1 priority. So if we built the entire grid by itself, add, edit, delete, we'd get it done. That's great and all, but maybe that only fit in 1 sprint. And emergency contact, which is the most important feature, the entire reason we built it, is left to do in sprint 2. But what if we left out edit? If we actually slice it up, we have a lot more agility there. The product manager could go in Jira and drag stuff around based on priority. And what do you know? Emergency contact is now in the sprint and it's delivered. And 3 weeks later, we add edit. All right, single large slice. Why can't we just do everything at once? Well, you're gonna fail. Especially, you know, this is probably not the right timing. Obviously, you can do this in less than 3 weeks. But let's say that it did take 3 weeks. If you develop everything at once, you're gonna deliver half of everything by the end of the first release. So that's another fail, in my opinion. We want to deliver every sprint. Epic description. All right, this is that. How am I doing on time? 33. We got time. Universal credit reports. As a Sage user, I'd like to pull client credit reports and associated data from universal credit reports so that I can make educated decisions for a loan or other financial products. Let's slice it up. How did I do this? First thing I did is I implemented the API credentials area. This is like in global settings, we created a new area. So they can enter their credentials, but they can't pull any credit reports, but delivered that and they were able to test it for a little bit. Then I pulled the credit report and parsed credit scores only, delivered that. Parse loan data only, save the credit report PDF, do some online loan application integration, joint credit reports, credit freeze pin, etc. Now, being a new employee, it didn't actually go perfectly. This stuff is hard to do. I think that we did deliver it in several slices, but not each story was delivered individually. I wish I could have done better on that, but I plan to do better in the future. So in reality though, this feature, what do I have here? 7 stories. You guys know that when I sliced this in Jira, it was not 7, it was more like 30 or 40 stories. These are way too big still. But it's a starting point. We've all got to start at some point. So I'm just trying to demonstrate an idea. You know, I can't show you guys 30 or 40 stories in this presentation. But these are the questions I asked product. Hey, can we deliver this feature without this other stuff? Can we just deliver credit scores and loan data and be done? Well, I don't remember what they said. They had some other reason. I think in some cases with another feature, they agreed that we could. But these are the questions we should be asking. Hey, I think that this stuff can fit in the first sprint. Can we just deliver after that? Would you rather have something rather than nothing? And then we can deliver the rest later? You're not forcing them to, but I think that we should try and propose this stuff. As a company, we move quickly. That's how we do it. So when you guys are slicing, I've had a few different people ask me already about slicing and if they've sliced correctly. So I created a little handout here that you guys can use if you've sliced correctly. Some of the criteria, if you slice correctly. Testable. When the story is complete, it's testable from a QA perspective. That means it is sliced properly. Delivers value. It needs to deliver tangible value when it's complete to the user. And then again, there should be several slices that fit in a sprint. You can't just slice one and then it fits just one story in a sprint. There are some situations where it's very difficult to slice it thin enough to fit in a sprint. I've come across that. There's exceptions here. To every rule, there's an exception. If a story delivers only value to an engineer and nothing to QA, maybe it's database story, that's probably not sliced properly. But there are exceptions. Maybe we're writing a story to, I don't know, do logging for the engineers to know performance. I don't know. That could deliver some value to the engineer and product. That would be an exception. Another smell is the story only touches one layer. Maybe it only touches the database or only the UI. Doesn't necessarily mean it was sliced incorrectly, but possibly. An exception there would be like, hey, we want to change out a logo or an icon for something that only touches the UI, but that actually could be potentially a full slice. Deliverable. When in doubt, slice smaller. You can. Jira is pretty flexible. If you guys accidentally slice too small, and let's say you're working on one story and you see the next story in line, and it takes an additional 5 seconds to complete it. Great. You made a mistake and sliced too small. That's not a big deal. You just drag 2 stories into the staging or completed column for QA when you're done. No harm, no foul. So, but if you slice too large and it's, you've taken on too much, it's a lot more difficult to go back in the middle of your sprint and then modify the story and slice it up and then recommit to it. That's a little bit more troublesome. And then point-based estimation, I mean, we can talk about that later and we can go over estimates if you guys would like. There's some indicators there that can help you determine if you slice too big. All right, so you guys can see if we committed to one big story versus several little stories. And the idea is that if we were to find a defect after we delivered the second small story, well, we just touched that code. So if they identified it quickly, it could take a few hours to fix. But if we delayed all risk until the end to a final delivery at the end of the sprint, defects could take longer, potentially days. And we're delaying the risk until the end of the sprint. Not good. So things that would help: separation of the databases between staging and development. If we're pushing a new story every single day and we're potentially changing database schema every day, adding new fields, etc. I know that we have backwards compatibility changes or whatnot, but it would make it easier to have dev have its own database so that we don't accidentally break staging in the middle of our product manager testing. Frictionless builds. I would say that, I don't know if we're fully there yet. We can do better. One-click builds, we do have that. Faster builds, it would be nice to have staging go faster. Reduce unnecessary merge complexity. When you guys start doing branches in the next few weeks, you'll start realizing, what the hell? What value does test branch provide? We should just eliminate this thing. Allow incremental QA releases from a private feature branch. This could provide a ton of value. It may not always be used. It depends on our branch strategy, but I think that it would be valuable to add that. And then obviously continually strive to make our builds and QA release cycle as frictionless as possible. SageWorks culture, we have SOUL. S stands for speed. A lot of this stuff flows into there. We want to get shit done fast. So I think embracing some of these concepts could provide a lot of value to even, our business culture in general. Facebook has a similar motto until they changed it when investors got all upset with them. All right. What else does the small slices do for us? It produces small wins and satisfaction on a daily basis. So small slices lead to greater team engagement, higher employee retention rate, and in general, probably more happiness with our careers and our lives in general. So I'm a big proponent of this. So let's go over waterfall at a glance and what we don't want to do. Waterfall is an old thing from the 2000s on how we build products. We typically spend a month or two doing requirements, another month working with the architects to design our software. And then finally, implementation maybe would take 6 months. And by the time we got to verification or quality assurance, maybe the user doesn't even want that anymore because it's taken so long for us to build whatever we did. Or maybe they've already decided on something new. They want it to be completely different. We're lacking the feedback cycle. Here's another timeline of what we do, what we deliver in Waterfall. At the top, you can see we deliver in the first sprint a couple dice and some money. Next sprint, a couple more dice and a little bit more money. And then finally, we deliver all this stuff in the last sprint. But Agile, it's pretty stable. We deliver a large box, some money and some dice, a couple large boxes next sprint, and 3 large boxes. Our velocity is increasing. We're completing more work as our team stabilizes. So the idea is we're delivering more on a consistent basis rather than, putting all the risk at the end. All right. How many guys have you done it? How many of you guys have done this where you go and get a ton of groceries and you try and, hey, I can carry all these in at once. So you load them up. I found this image on Google, and apparently, I don't know if this is a strongman competition carrying cornflakes or what. This guy is trying to carry like 20 grocery bags without making a second trip. It's ridiculous. Sometimes I think that we do that in Waterfall. If we start all the stories all at once, and then we test them all at once after the code freeze. I've worked with some companies where we don't have a code freeze at all. Why? Well, the stories are developed and tested at the same time. We develop the first story, story 1, and day 1 and 2, and tested in day 3 and 4, and then it's fully completed and staged for full deployment. It reduces risk, and look, you can even develop and test all the way until day 9.5. Risk is reduced to the last story, so if you guys don't get that done, it's not a big deal. They call it stop starting and start finishing. So rather than starting all of these stories and getting them all half done, start 1 or 2 stories and completely finish them. Done. I think that's probably a separate discussion, but definition of done, what does it mean to be done in Jira? Is it tested, deployed, whatever? But the idea is we want to finish things and stop starting them. Push versus pull system. So it's really common for product in general. I've seen this in multiple companies that they think, hey, if we just pack all of this load onto the engineers, they'll just be so overwhelmed that they'll just get a ton of stuff done because they'll have so much on their plate. Well, I don't know if I really agree with that. I think that it can just cause a lot of problems and being overwhelmed. Pull system states just the exact opposite. It says, hey, we'll limit the amount of work in progress. We want the engineer to be done with what he's working on before he works on the next thing. So this is a good demonstration of that. You can see if we pack all of that work into a single sprint with the idea, hey, hopefully they'll get it done. The cruncher is probably going to be overwhelmed and sit there and crunch on it for a long time. Versus if we slice things really small and then we put them into this simple, efficient system, they go through perfectly. Yeah, so this way, the one on the top right, there's no explicit limit on the amount of work in progress. Pull system on the bottom right explicitly limits the amount of work in progress by only working on a few stories at once. And as soon as story 1 is completed right here, then we can start on story 3. Other benefits of small slices. Which one would you guys rather estimate? The one on the right, which is the enormous feature as a whole, or slice it into small stories and estimate those each individually? We can probably, like I said, estimate, this is probably a separate discussion, but there are benefits to slicing it smaller. So what if you guys want to do this stuff? Where do we start? Well, change is not always easy. And if one of the team members decides they want to do this, maybe some of the other team members aren't on board with it. And there will be resistance. In fact, there will be chaos. You guys are not going to be experts at this at the first go. You're probably going to be like, hey, I sliced it correctly, Kevin, look at this. And I'm going to say, no, that's still horizontal. Sorry. I do it too. In fact, I've done it for years. In the middle of the sprint planning session, I catch myself slicing horizontal by accident. So just be prepared for chaos as everybody finds their new role in the team and as we reintegrate. There will be a period of less productivity as we're trying to reform our processes. In addition to that, we'll probably go through the forming, storming, norming, performing process all over again as each team member finds their role in the team. Maybe there's a specific person or a group of people that help slice it. And again, this slicing can be done by either product managers or the engineers. It doesn't really matter, or you guys do it together. In fact, after some time, maybe the product managers start learning on how the engineers like it to be sliced, and they can preconceive that slicing and deliver the specs to the engineers in this manner. That could save time. Team morale, like I've seen it amongst multiple companies I worked for, the product manager or the CEO or whoever looking at me like Arnold on the left, do it, I need it out the door now, get off your ass, get it done. But in reality, positive morale is going to be a lot more effective for any team. Let's have a beer and do it again next sprint after we just had some success. For some reason, that really resonates for me. Delivered on time, having team success. We want to be like Borat over there, calm and very excited. All right, final thoughts. Vertically slice into deliverable pieces. Smaller the better. We want to increase the velocity. That's why we do this. We want small wins and commit and release to QA often. Jumping into it. So have you guys ever seen the product manager who says, hey, Kevin, we'd like to do this enormous feature. And it's maybe the equivalent of building, I don't know, a baseball stadium. And he says, cool, how long will this take? We want to do it in the next sprint. Well, I'd imagine that you guys probably all have a look similar to this guy on the bottom. You're freaking crazy. We need to step back and really figure out what that's going to take to do it. There's no way I can estimate that. Need to break it up. This could potentially be a situation for a spike, or maybe taking a deeper look into it. So Agile software development, spike is a story that cannot be estimated until the development team runs a time-boxed investigation. So there's a few things that we should focus in this description here. So cannot be estimated is a key element. If you can estimate it, there's something going on. It's probably too big of a story or feature. It needs to be broken up into smaller subset features that could maybe be released in increments. And obviously the time-boxed investigation, we want to avoid, a 2-week investigation into a single feature that after we actually estimate it may not actually be pulled into the sprint. So we don't want to waste too much time and get into this constant analysis phase. So you might consider spike if, high level of uncertainty, a lot of risk. Maybe there's a concept that I call eggshells, where you're stepping on some older code, which is maybe there's no unit test and it's spaghetti code. There's a high level of risk that you're going to break something. You probably want to do a spike to sort of investigate that to see if this is really something that your estimate is really going to hold true, or if you have to, put a lot of buffer on it to make sure that you're going to either encase the existing code of this unit test if possible, refactor it, or just to deal with the additional bugs that you're going to have to go through. Kind of dealt with that. Several different companies. A new technology or framework that's being considered, maybe you go to the architecture team and they say, hey, we want to use this new logging technology or this new data storage technology. Maybe you want to do NoSQL data storage. I don't know. Sometimes you'll do like a prototype during the spike, but mainly you want to start investigating it and really get a feel of what you're about to do so you can get a better estimate. Prototype, steer the direction of the project, and estimate. Yeah, so I put a can of worms here. That's really a good indicator if a good indicator that a spike would be a good idea if you're really getting that feeling that you have no idea what's going on as we're kind of going into the sprint during planning. Types of spikes. So, I mean, it's not really a formal way of identifying a specific type of spike, but typically you can have spikes for a number of reasons, and sometimes they're technical and sometimes they're functional. So maybe the spike would be, hey, we've got this, enormous report that needs to be done, and maybe the spike is to see the performance impact if we're pulling a whole ton of data together on how we're going to actually approach that. Implementation approach, maybe the architectural team is asking, hey, let's go for this architectural pattern and we want to do it this way so it's maintainable in the future. Maybe you want to throw in a spike so you can learn that new pattern. Functional, how to slice up the work. The example that I gave earlier, like building a baseball stadium, that would really fall into that category right there. How to slice up the work. Maybe the first thing you do is build the field, and then you build the bleachers, and then you build the food stands. I don't know. How to organize the work. Where's the risk? Is it, again, is there an area where it's going to be a huge performance hit, or is there an eggshells situation where you're kind of stepping on eggshells, you're going to break a ton of stuff? And a lot of times you actually end up digging into the story or feature in more detail, and you end up identifying gaps and requirements. These are areas where potentially the product managers, hey, I forgot to add that. Oh, okay, cool. We got to add a new feature or 4 or 5 features because we forgot about this section of how it's going to impact this other area of the system. All right, you don't need a spike for the majority of stories. The spike should not be the norm. It should be the exception if we're doing things correctly. So if you have good confidence for an estimate, maybe you've worked in that area before, you don't need to do a spike, and yeah, there's always a level of uncertainty. That's what an estimate is. An estimate is never correct. So we need to embrace that concept. Simple tasks or stories, things like adding a field here or there, or or maybe you just have the confidence of this Turkish chef here on the right, which could be a good thing. Planning a spike. All right, so the product manager is not necessarily going to come to you and say, hey, let's do a spike on this. He's going to expect that you're going to get it done in a week and have it delivered on his desk in a silver platter. So the engineers need to voice the concern. And one of the main things is that we want to do it prior to starting the sprint. Now, you might be able to pull off doing the spike during the sprint, but it's not a good idea. It's probably going to impact the time that you're going to spend working on the sprint. So it's always better to start the sprint with the spike already completed, meaning you already have all your stories and all the clarification dialed in. The last thing you want to do is do the spike during the sprint and end up realizing that the work that you committed to is a lot more than you originally thought it would be. So then it impacts the sprint. You're going to do a time crunch at the end of the sprint, and it's just not a good situation for anybody. Time box shall be agreed. So most of the teams that I've worked with typically time box is somewhere between like 4 and 8 hours. You could go more if it's something crazy, but typically that should be enough. And again, avoid analysis paralysis. Basically, you want to get just enough information so that you understand what's going on and you can estimate the sprint or estimate the story. There will always be unknowns. There will always be some level of uncertainty, and that's fine. Outputs might include decision-making information. Hey, if we do this feature, this other area is going to slow down. That would be something that could be valuable to the product manager. Estimate for the original story, obviously. Risk identifying areas of complexity. Impact analysis, again, eggshells. Are you going to break something else? Are you going to have to rewrite another area as you're taking on this new feature? Performance is another big one. Sometimes you'll do a spike specifically to identify performance impact. High-level plan, maybe that's how we slice up the features. Simple prototype, yeah, possibly split an epic into multiple stories. An epic would be like building a baseball field. You know, that can't be done necessarily in one sprint. How can we slice it up so that we can deliver it in multiple pieces over multiple sprints? Identify risk. So I hope you guys like my memes. I tend to do this so that you guys don't fall asleep. All right, so here's a scenario that I was actually faced this sprint. Product manager says, hey, we'd like to implement third-party vendor universal credit reports. Wants an estimate. Being a new guy, I'm like, well, I don't even know the system. I'd like to kind of investigate. I didn't really tell them that I'd do it. It was kind of just assumed that I'd need some time to go figure out what's going on. So I basically did a spike one day. I told them I needed time to investigate, talk to a few different people. The results, analyzed the API documentation, tested it in Postman, did a few different requests, reviewed the use cases in detail. I didn't really help them identify new areas because I didn't know the system that well, but potentially you could. Engineering strategy reviewed by architectural team. Ashton and I decided to go with the NuGet package. Split up the story into different, slice it up into different stories, and kind of the idea was that we can, release these to staging incrementally throughout the sprint.